AET 105, Chapter 11, Inductors. First of all, an inductor is basically a coil of wire. The symbol 99% of the time we're going to use looks like this. It's in figure 1120 in the book. First equation for inductors is the flux density, B, equals phi, the number of flux lines passing through an area A divided by A. Phi is in Weber's or Maxwell's, and the area is in meters squared or centimeters squared, and flux density is in Weber's per meter squared, which is equal to Tesla's T, or Gauss, which is Maxwell per centimeter squared. When they say lines of flux, this is like typical right here of a magnet. So you have flux lines going through the magnet, and you also have shown through a conductor like this. The next equation is the magnetomotive force, which is script F, equals N, which is the number of turns in the coil, times the current through the coil, and F is in ampere turns AT or Gilbert's. Then you have the permeability, which is like the permittivity of a capacitor. Mu 0 equals 4 pi times 10 to the negative 7th Webers per ampere meter. That's AM. So mu 0 is the permeability of air, mu is the permeability of the material that's given, and then mu sub r is mu divided by mu 0. Mu r is the relative permeability. It's dimensionless. It defines the max working current of the inductor, very similar to the capacitor. Then you have inductance, which is L in henries equals mu times N squared times A divided by L is the length, this L, which is really, it should be a script L. And if that helps at all, it's kind of a small formula. Anyways, L is inductance in henries, and the induced voltage is V sub L equals L times di times L divided by dt, which is L times one current divided by the original current, or subtracted, then divided by the time at T2 minus T1. So it's changing current over the change in time is the induced voltage. The way the book is going to teach this is I sub L equals E divided by R times 1 minus E to the T over tau, with tau being L divided by R. This is in an LR circuit. V sub L across the inductor is E times little e to the minus T over tau. V sub R equals E times 1 minus E to the minus T over tau, and I sub M, which is a steady state max current after 5 tau, equals E divided by R. And the rest, all the variables are defined right here. A lot of them you're familiar with. Tau is, again, it's different for the RL circuit. For the RC circuit, it was just R times C. Now it's L divided by R. And all these other numbers you're pretty much familiar with.